Hello, coding wizards and wizardesses. Today we're going to pull rabbits out of hats with Python. Not real rabbits, but functions. Python's magical way of performing coding tricks again and again without a wand. Functions in Python are like those little gadgets you wish you had in your kitchen. Do a task once, use them forever. Let's dive into the art of concocting functions in Python. Think of defining a function as writing down a recipe. It's not enough to just say, make a cake. You need the how-to guide. Defining a function in Python starts with the keyword def, followed by the function name and parentheses. It's like naming your spell before you cast it. Inside the parentheses, you list ingredients known as parameters, which are optional but oh so useful. In this little charm, say, _hello is our spell. When cast, it greets the world of Python lovers. Simple, yet effective. But what if our spell needs specific details? Enter parameters, the secret ingredients. Parameters allow our functions to be more dynamic and versatile. Here, greet_person takes one parameter, name. It's like a personalized greeting card. Fill in the name, and it creates a custom message. Choosing the right name for your function is like picking a title for your favorite book. It should be descriptive and give a hint about what the function does. A well-named function can be worth its weight in gold, or at least in coding efficiency. Calculate_area. Now that's a name that tells you exactly what it does. No mysteries here, just good, clean code. Parameters are the variables listed in a function's definition. They're like the empty seats in a theater, waiting for audience members, arguments, to fill them. Each parameter is a potential for something exciting. In our mix_potion spell, ingredient 1 and ingredient 2 are the seats waiting to be filled. But what will we mix today? That's where arguments come into play. Arguments are the actual values you pass to the function when you call it. They're the VIPs arriving to fill those waiting seats. Let's call our mix_potion function with some exciting ingredients. By saying dragon scale and phoenix feather, we've just filled our parameter seats with some magical ingredients. The potion is brewing. But what if some seats are so popular they always fill up the same way? Enter default parameters. They're like reserved seats. If no one else takes them, they're automatically filled with a default value. In our cozy brew_t function, if we don't specify the type or temperature, it defaults to a hot cup of green tea. Comforting, isn't it? Sometimes you don't know how many stars will show up. That's when variable length arguments, *args and **quargs, steal the spotlight. They're like having expandable seats in your theater. With asterisk dishes, we can prepare as many dishes as we like. And ** special instructions lets us add specific touches to each. A feast fit for a king. Calling a function is like pressing the play button on your favorite song. You've set it all up, and now it's time to enjoy the tune. In Python, you call a function by using its name followed by parentheses. In our little magical act, perform_magic, is the cue for our Python magician to spring into action, bringing the trick to life. Most functions need a little more than just a cue. They need details. Passing arguments to a function is like giving your magician the right props for the trick. By calling magic_trick with ace of hearts and 3, we've just set the stage for a spectacular card trick. The details make the difference. Some functions are more than just performers. They're also fortune tellers. They predict or return a value. When you call these functions, they hand you back a piece of information. In this mystical prediction, predict_future whispers a fortune into our ears, and we store it in fortune. It's like getting a secret message from the future. Functions in Python can be quite sociable. They can call other functions. It's like having a party where everyone is mingling and creating an even bigger buzz. In our grand show, start_show calls prepare_stage, which in turn calls perform_magic. It's a chain of events leading to an enchanting Python extravaganza. A return value is what a function gives back after it's done performing its magic. It's like asking a genie for a wish. You ask, call the function, and the genie grants your wish, returns a value. In our calculate_sum spell, we ask for the sum of two numbers. The function does its magic, and then returns the answer. Capturing a return value is like catching a star. You invoke the function and hold on to the value it gives back. Let's see how we can use this in our code. By calling calculate_sum with 5 and 7, we catch the return sum and store it in total. It's like bottling a bit of starlight. Some functions are like silent movie stars. They perform without saying a word, or in our case, without a return value. These functions do their job but return a default value of none. In display_message, we send a message out into the world, but don't return anything. So Python quietly hands back none, like a mime delivering an invisible box. Return values are powerful tools. They let you build functions that not only perform tasks, but also communicate back, allowing for more complex and interactive code. Here we use the return value from calculate_sum directly in a conditional statement. It's like using the starlight we bottled earlier to guide our path. A nested function, or an inner function, is defined within another function, known as the outer function. It's like having a secret compartment in a treasure chest where you keep the most precious items hidden. In this mystical code snippet, inner_function is our hidden gem, safely nestled within outer_function. It's only accessible from its enclosing function, like a secret spell known only to the master wizard. But why, you may ask? Do we need such secrecy in our code? Nested functions can be quite handy for encapsulating functionality, making it accessible only where needed. It's like having a private diary where some thoughts are meant just for you. Here, clean_data is a private function within perform_complex_calculation, handling the nitty-gritty so that the outer function can focus on the broader picture. Scope refers to the region of your code where a variable is accessible. It's like having a VIP pass to specific areas of a grand castle. Some passes, global variables, grant access everywhere, while others, local variables, are restricted to certain rooms, functions. In our mystical example, global_spell can be invoked anywhere in our code castle, but local_spell is confined to the perform_magic function. Step outside, and it vanishes into thin air. The lifetime of a variable is the period during which it exists. Global variables live as long as your program runs, while local variables disappear after the function's curtain call. It's like characters in a play. Some are mainstays, others just guest stars. In conjure_spell, temporary _spell makes a brief but memorable appearance. Once the function ends, the spell dissipates, gone until the next invocation. Understanding the difference between global and local variables is crucial. It's like knowing whether your magic wand has unlimited range or just works in your own backyard. Misuse can lead to unexpected enchantments or lack thereof. Here we changed global_spell from anywhere, but local_spell remains a secret within modify_spell. The global enchantment now echoes throughout our entire code. In the world of nested functions where functions reside within functions, non-local comes into play. It's a bit like a walkie-talkie connecting two friends in different rooms of a house. The non-local keyword allows an inner function to access a variable from its enclosing scope, but not globally. In our whimsical example, secret_message starts as a declaration of Python love in the outer function. But within the inner function, thanks to non-local, we can alter this secret. It's as if the inner function whispers a new secret to outer, changing its initial confession. A lambda function is a small, nameless function defined by the keyword lambda. It's like a magical incantation, brief, potent, and to the point. These functions can have any number of arguments, but only one expression. In our example, magic_multiply is a lambda function that takes two arguments, x and y, and returns their product. It's short, sweet, and gets the job done with a flick of the wrist. Lambda functions shine in scenarios where you need a simple function for a short period. They're like disposable gadgets. Use them once and move on. They're particularly useful in higher-order functions that expect a function as an argument. Here, we use a lambda function to square each number in the numbers list. The map function requires a function as an argument, and lambda fits the bill perfectly. Lambda functions embody the spirit of simplicity in Python. They encourage concise and functional coding. However, the trick is to use them wisely. They're not suitable for complex operations, where a named function would be clearer. In the case of our addition spell, a lambda function is perfect. But for more involved sorcery, a named function like complex underscore operation is the way to go. A recursive function in Python is a function that calls itself in order to break down a problem into smaller, more manageable pieces. It's like solving a labyrinth by walking through it, marking your path, and retracing your steps when needed. In our count underscore down enchantment, the function keeps calling itself with a decremented number until it reaches 0, creating a magical countdown. Every recursive function needs a base case, the exit condition. It's like having a safety net to stop the endless fall. Without it, you'd tumble down the recursion rabbit hole forever. Our base case here is when the number becomes 0 or less. It stops the function from calling itself endlessly, preventing a spell of infinite looping. Recursive functions are not just a show of coding acrobatics. They excel in situations where problems can be divided into similar subproblems. They're stars in solving complex algorithms, particularly in tasks like traversing trees or solving puzzles. Take, for example, our factorial function. It elegantly calculates the factorial of a number by multiplying it with the factorial of the number just before it, all the way down to 1. And there you have it, the spellbinding world of functions in Python. With their ability to repeat tasks without repeating code, functions are like your personal team of magic assistants. They make your coding life easier, cleaner, and definitely more fun. Stay tuned as we continue to unravel more Python mysteries. And remember, in the world of programming, a well-written function is worth 1,000 lines of code.